All right, let's look at our second customer case study. So this customer is named Ace Inc. Um, they're a software service provider who has a customer base across the globe, so it's not limited to a specific geography. They're a multi-cloud infrastructure with multiple data centers which are connected with the public cloud provider infrastructure. Their cloud journey started with AWS as the primary cloud, but since it has grown rapidly into Azure and GCP as well. So they're in multiple AWS regions. They're in a single region in Azure and GCP today, but all the infrastructure there is very critical. So they, being software service provider, can usually not dictate which location or cloud their customers would want to connect to. So some of their retail customers don't want to connect to Amazon, as an example. So they need to be able to provide their software services from any cloud that their customer may want them to connect to. Maybe their customer already is present in Azure or GCP, and they want to be able to consume the services from within the same cloud. The applications team at Async, they will be the driving force in cloud adoption, as in most organizations. So networking and infrastructure must be able to support the needs of the application almost at an on-demand basis, because they may have new customers being onboarded in new regions and new locations. For example, they may have customers onboarding in South Africa where they don't really have any presence, but let's say Google has a region there, and they may say, well, Google is locally present. Can you connect us locally? There are also GDPR and other data privacy requirements where the customers may not want their data to leave the physical country, and they want to be hosted in the local region or whatever is the closest to them. So the application and business team, they will be driving the cloud adoption, and infrastructure just need to be ready to provide any services in any region almost at an on-demand basis. The overall desire is to automate as much as possible while reducing redundant work, especially for infrastructure, because the applications that they run, the virtual machines, they are pretty standard, so they can spin up those virtual machines in any cloud, any region. Hence, they want networking to be similarly available, and also they don't want networking to say that, oh, we need to go in OCI and I need to redesign my infrastructure for OCI now. They should be able to consume networking services consistently across and automate all of that as well without having to write new Terraform code for individual cloud providers. And because they're customer facing and customer focused, they are required and mandated to reduce the mean time to resolution for any issues. This is one of the critical requirements that to meet the SLAs that they provide. They need troubleshooting capabilities, visibility, irrespective of the cloud provider and location. Now let's look at the technical requirements. So first of all, the networking team wants seamless connectivity between applications hosted in different cloud providers. They don't care where the applications are. They should be able to connect them seamlessly without having to manually build any connectivity. They should be able to expand into any region of any public cloud provider as the business demands. On-prem data centers still host critical services, and they must be fully connected over private links like Direct Connect, Express Route, and so on and so forth. With dynamic routing, they want to be hands-off and no manual static configuration. Different BUs and apps will need fully isolated environments with next-gen firewalls on demand. So some business units may want next-gen firewalls, some may not want it, some may want to have it and also drive the policies, while others may say that we want central IT to manage it for us, right? So there may be these various requirements depending on the application, its criticality. Encryption should be available wherever needed, because in the cloud, nothing is encrypted from a data path perspective. So they want to make sure that the on-prem to cloud connectivity and within the cloud and between cloud, wherever they want encryption, they should be able to encrypt that data. Access to S3 in AWS must be limited to corporate needs. They don't want the their direct connects and stuff to be consumed for non-corporate S3 access. There's a lot of security, data leakage, and other privacy concerns. And any application that needs internet access must be logged down to approved URLs. It shouldn't have full-blown and internet access. So now let's look at the design which would fulfill this requirement. So it's a multi-cloud customer, so multi-cloud design. So let's simplify this, right? Excuse me. So let's look at the first region because as they mentioned, they started with a single region in AWS or AWS as their primary cloud provider. So that's where the majority of their initial infrastructure was built. That's where the dev, test, UAT, and other environments are as well. So the idea here is they started with Aviatrix controller as a central management control point. So Aviatrix controller is that multilingual device that talks AWS API, Azure API, GCP API, OCI API. It talks Fortinet API, Palo Alto API, Checkpoint API. It understands VPC routing in AWS and transit gateway routing and DX gateway routing. It understands the UDRs and of Azure and the global routing of GCP. It understands BGP. It understands static routing. It understands software-defined routing. It understands IPsec. So it's this multilingual device that has end-to-end ability to translate and provide an end-to-end correct network. So the first step was to deploy Aviatrix controller, and they chose to deploy in AWS Region 1 in North Virginia. Copilot is the visibility tool to meet the visibility and reducing the mean time to resolution requirements. The Copilot, as you saw in previous demo as well, provides a very easy way for customers to visualize their entire environment and also troubleshoot just right from the view and the topology, and also be able to look at net flow data and other trends. Different firewall vendors are available, so you can use Fortinet, Palo Alto, Checkpoint. So Async wanted the flexibility to insert different kinds of firewalls depending on price, performance, availability, and other reasons. As mentioned in the requirement, they need to be able to terraform or automate their network deployments. So instead of creating terraforms for network infrastructure deployment in each region, they decided to terraform it against Aviatrix controllers. So they would spin up the VPCs and VNets and VCNs by making API calls to Aviatrix controller, and then they will spin up the gateways and bespoke gateways and all the attachment through that. So this way they will avoid having to build independent individuals terraforms for each cloud provider, at least for the infrastructure perspective. They had standardized on Splunk as their logging platform, so Splunk integration with the dashboard that Aviatrix provides for Splunk was very handy for them to operationalize very quickly. This is one of their data center, which is connected over direct connect to Aviatrix transit in this region. The dark orange line depicts encryption at data path. So here you see line rate encryption over direct connect. So this is giving them 10 gig direct connect encrypted tunnels to each of their AWS regions. So this is region 1, North Virginia, and then going to region 2, Ohio as well. Now let's look at some of the requirements in here. So they wanted the different environments or the applications to have isolation. So having an Aviatrix transit dedicated for each of these environments met those requirements. So essentially they have that pod-like architecture that we spoke about before. So this green production is one pod for them that they can spin up independently. Any VPCs in here are connected to each other over encrypted tunnels, and they have the next gen firewalls inserted. The production team is managing the firewall rules that are required for these applications in here. Now, UAT did not want a next gen firewalls in here. So there's no next gen firewall. So you can see very easily they were able to satisfy the requirement of inserting next gen firewall wherever they need or wherever they don't need, and still have these environments connected to each other. They also wanted to leverage native constructs. So, for example, AWS Transit Gateway for some non-important, non-critical workload to be connected. Now, let's look at the second region. So second region, again, is the same repeatable architecture where they're able to repeat the same pod-like characteristic they had in region 1 into region 2. Now in here, they also wanted to add the private S3 access. So as we learned earlier, the access to S3 from on-prem is usually over public WIF, which is basically there's no control to limit that traffic to approved corporate buckets only. So private S3 access from Aviatrix allows the customer to provide private S3, private IP-based access to the S3 buckets from on-prem. So essentially, this load balancer was spun up by Aviatrix controller, and bunch of S3 gateways were spun up behind it, providing S3 access. So this was a dedicated VPC for that purpose specifically. Again, the same architecture of repeatability between different environments is also present in here. As you can see, some of the environments that do not require encryption, for example here, and the workload is non-critical, they don't really need the visibility and troubleshooting powers in these dev environments. They chose to connect it to the native transit of AWS. Now let's look at some of the other cloud providers. So they expanded into GCP and Azure in different areas. So GCP, as you can see, again, that same repeatable architecture. So this is satisfying most of their requirements where, the repeatable architecture to be able to terraform across different regions consistently, uh, grow into different cloud providers with, minimal effort, and the infrastructure team be able to provide these services almost on demand. Same thing for Azure as well. So here they had some applications in Azure they needed access to SaaS services for API consumption, and they didn't want to open full internet access, so they did a centralized FQDN where the bunch of Aviatrix gateways providing layer 4 firewalling based on layer 7 URLs. So it's a very effective way for them to be able to provide internet access to these applications while limiting it to specific URLs only. Multiple data centers all connected via encrypted paths over to the cloud providers. So as you can see, this is a consistently repeatable architecture that async is able to replicate in any region, any cloud provider at their whim. Hope this puts together all the different use cases and problem statements that we learned in our session earlier.